Today's lesson is section 11.3, chapter 6.1 in the textbook, Degrees and Radians. First, we have to discuss what a radian is. It's the measure of the central angle, so this theta, that intercepts an arc equal to in length to the radius of the circle. So what's that saying? Is saying that if this length of the arc was equal to this radius, this theta is now equal to 1 radian. Okay. So radian is just another unit of measure for an angle. Just as we have feet and meters, we have radians and degrees. So now it's extremely important that you make sure that you put the degree symbol on all of your angles that are measured in degrees. So I should be able to convert back and forth between degrees and radians. So I want to convert 30 degrees to radians. So I'm going to take my 30 degrees and I am going to divide by 180 and multiply by pi. You are using pi as if it was a variable. You're not actually going to plug that into a calculator. You are going to reduce this fraction. So first cross off your zeros. And 3 goes into 18 6 times. So you have 1 times pi, which is pi, and then 6 is left in the denominator. So you have pi over 6 radians. To convert radians to degrees, you're going to take your radian, you're going to replace the pi with 180 and simplify. So 2 into 180 is 90. So you have 3 times 90, which is 270. Okay. If, for example, you are given 2 radians, and you want to know what that is in degrees, you are going to take and your 2, multiply by 180, and divide by pi, which in this case, since you are now not going to have a nice neat number, you are going to use the calculator on this. So 2 times 180 divided by pi. So you have 114.6 degrees. Okay. Now, we're continuing with our study of trigonometry, which means measurement of triangles, but we're going to start just talking about angles in general, since we're talking about converting. So on our angle here, when I start from here, this side is called the initial side, and this side is called the terminal side. Okay. And of course, the opening would be called theta. When I am talking about an angle in standard position, I'm going to have my axes, and my initial side is sitting along the positive x-axis. So this is your initial side. And this would be your terminal side. Now, you learned in geometry when we were talking about rotations that you could rotate clockwise and counterclockwise. This is why the counterclockwise were positive rotations and the negative rotations were clockwise. So, with this being your initial side, this direction would be a positive degree positive angle measure. If I went clockwise from the x-axis, this would be a negative angle measure. So this leads us to having multiple ways that I could name a single angle. These multiple ways are called coterminal angles. So they are the angles that have the same initial and terminal sides. So for example, if I have a 30-degree angle, and instead of going counterclockwise, I went clockwise, this would be negative 330 degrees, but it does give me the same exact angle opening. So I could say that 30 degrees and negative 330 degrees are coterminal. Right? In addition, if I did more revolutions around the circle, so I started at my initial side and I did all the way over like this, I did an extra rotation around the circle, and circles, as we know from geometry, are 360 degrees. 30 plus 360 degrees would get me a second coterminal angle of 390 degrees. So 30, negative 330 degrees, and positive 390 degrees are all coterminal angles. This also leads us to why the quadrants are numbered the way they are. Your first quadrant is here because your angle would start in quadrant 1. We go counterclockwise, so this quadrant is called quadrant 2. This quadrant is quadrant 3, and this is quadrant 4. Notice you use Roman numerals to name the quadrants. A little review from geometry is our degree measure is the rotation from the initial side to the terminal side. We have several important angle measurements that we deal with in Algebra 2. The first one is 45, the next one is 90, 135, then 180, 225, 270, 315, and 360. If you notice, I have taken the circle and divided it into eighths. If your axes are the other division lines. Okay. Now, my next important angles take and divide up into 12ths. So I've got 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 360. So these each go by 30s. You need to memorize these because we will be doing something with this on Friday. One last thing to remember is our names from geometry. An acute angle is an angle whose measure is between 0 and 90. A right angle is an angle whose measure is 90. An obtuse angle is an angle whose measure is between 90 and 180. A straight angle is an angle whose measure is 180. Complementary angles are positive angles whose sum of their measures equals 90. Supplementary are positive angles, so both of these say positive, whose sum of their measures equals 180. So we got 90 and we got 180. And this is your homework assignment. Now, looking at the bookwork, it is going to ask you what quadrant the angle lies in. So you need to have a good judgment of where each of them land. Okay? And you're only doing part A in these questions. You're doing the odds and part A.